I'm going to take a few minutes and talk about the properties, general properties of weathering steel, and then get into some of the design and detailing issues that you need to be aware of to ensure a successful application of weathering steel. Well, the bullets come out a little differently on your computer than on mine, Dan, but that's okay. First of all, weathering steel is a high-strength, low-alloy steel, different from regular carbon steel primarily because it has a higher copper content. Copper content for a weathering steel is at least 0.2%, whereas with a regular carbon steel, the copper content will be 0.02%. So there's a lot more carbon, there's a lot more copper in weathering steel. It comes in several different strength grades. You can see, as indicated by the W at the end of each one of those, W is for weathering steel. Earlier versions of the ASTM A709 specs had a regular grade 70 without the HPS in front of it or the W at the back of it, and also a 100. The only 70 and 100 grade materials that are now shown in the A709 are these HPS steels. So the old 70W and the old 100W are no longer there. You can expect up to 4 times the corrosion resistance of carbon steel using a weathering steel, and that's primarily atmospheric corrosion. Weathering steel is an improvement only insofar as atmospheric corrosion is concerned. If you took a piece of weathering steel and a piece of regular carbon steel and threw it in the water, they would behave the same if you left them there. If you use them for piling in the water or something like that, they're going to behave the same. Weathering steel requires wet and dry cycles in order to properly perform. And what happens is, during those wet and dry cycles, it forms a protective oxide coating, a tightly adherent patina that's composed of corrosion byproducts. So when it first gets wet, it was first exposed to moisture, it will corrode a little bit. That corrosion then sticks on the surface and protects the remaining steel underneath. This is a picture of a good protective patina. It's kind of hard to see in this picture because it's pretty much all the same color. We will see a couple of other pictures from this same bridge that will give you a better sense of what that patina should look like. Is weathering steel commonly used in Indiana? Anybody? Okay, I see a couple of heads going up and down. This patina we talked about, it's a thin layer of dense corrosion byproducts. It acts as a skin to protect the remaining steel underneath it against further corrosion. During this, the forming time for this patina, you might lose 100 mils of thickness, maybe 150 mils of thickness. A mil is a 1/100th of an inch, I think, so, or rather 100 mils is a 1/100th of an inch. So you really don't lose any thickness if the patina forms correctly. It's been in use in the United States since 1933. It was first developed by U.S. Steel for use in coal hopper cars. As coal would be in a hopper car coming its way east to the steel mills from the west, these hopper cars are all open top, and that coal may spend a lot of time sitting in rail yards and train yards, getting rain washed on it, sitting out in the weather. The rainwater coming through into the top of the hopper cars would leach some of the sulfur out of the coal, and it would just corrode the bottom of these hopper cars in no time. So for their own self-serving purposes, if you will, U.S. Steel and Bethlehem Steel had to come up with something just so the bottom of these hopper cars would stay intact long enough to get the coal from the coal mine to the steel mill. So that's what caused its first use. It was first used in highway bridges by the New Jersey Turnpike in 1964. The New Jersey Turnpike is a major proponent of weathering steel. They just love this stuff. Again, they were the first to use it. They saw the advantages of not having to come back and do any maintenance painting later on over the years. Turnpikes being revenue-generating properties, they didn't want to do anything that was going to slow down the revenue stream, that is the traffic stream. And I believe that the New Jersey Turnpike has not once reported any of their toll-paying customers complaining about the color of weathering steel bridges. So it's not a problem for them. I noticed as I was coming up 465 from the airport yesterday, the 465 widening has some new overpasses on it of that other material, and they've all been coated to look like weathering steel. I don't quite understand that. Something's not right about that. But the exterior faces of all those precast beams and the bottom flanges have all a real dark brown coating on them that looks kind of like weathered steel does after it's been out in the environment a couple of years. Anyway.
It's when they start painting in bolt heads that you know that there's a real coating.
That sounds like an excellent requirement to me. Maybe paint on some splice plates and everything too? Yeah, very good. I mentioned the high-performance steel earlier. High-performance steel, one of the things that was on the list wish when they were developing HPS was that it have improved weathering characteristics. So HPS does actually have a little bit better weathering properties. I would say it's not significant. I wouldn't be speccing HPS just for the improvement that comes in the weathering and the corrosion, the anti-corrosion properties, because it's nominal. It's it's a 10% improvement maybe, and it comes with the package for HPS. I don't know that anybody is requiring HPS just for the improved weathering, but it's in there. When properly applied, a bridge made of weathering steel will give you a nice, simple, low maintenance, easy to take care of bridge, not necessarily unattractive depending on the setting. If you've got a lot of pedestrian traffic underneath the bridge, many states and jurisdictions will require that the bridge be painted, even if it's made of weathering steel, just because some people the general public doesn't understand that the rusty bridge is not a bad thing. It's supposed to be that way. It's saving the money in the long run. Insofar as where do you put it, how do you use it, what's good about it, the list of benefits shown here primarily have to do with the fact that you're not painting it at the beginning. You've got lower fabricating cost, given that the fabricators probably would have been putting some paint on it, shorter fab time, no field painting, minimal maintenance, lower life cycle cost. All of these things are because I'm not painting it either first time or throughout the life of the bridge. There are some places where weathering steel won't work or has proven to not be the best choice for materials. And that's because primarily it doesn't get these wet and dry cycles that I mentioned earlier. If you're in a foggy coastal region where the steel is likely to remain damp, you don't get that protective patina to build up. If you're in a place where there's tunnel-like conditions, and I've got a rendering of such a place later on, same thing, the steel constantly is being wet by water splashed up from the roadway below in that tunnel, if you will. And in the winter, if that water has de-icing salts in it, which here in the northern climates it probably does, so it's going to stay wet in the winter and it's going to be constantly be exposed to the chlorides from the salt. Not a good application for weathering steel. The patina will not form properly. And finally, you have to evaluate if you're in heavy industrial areas that have corrosive chemicals just in the environment. We're finding there are very few of these places left anymore. The Environmental Protection Agency has done such a good job cleaning up industry and what comes out of the smokestacks from most industry that there are very few areas anymore where that this is really going to be an issue. I don't know. We've done several site evaluations over the years, and I don't know that the metallurgy experts have ever identified a site even where they thought that just the industrial pollutants were not going to be conducive to using weathering steel. We did a site evaluation just outside of Newark, New Jersey, not too long ago, well, a while ago now. And if any of you know Newark, New Jersey, and the area where the turnpike comes up through northern New Jersey, I mean, there's chemical plants and refineries, and it's not a pleasant-looking place, and there's a lot of heavy industry. But even there, the metallurgist said, no, the air is fine, insofar as using weathering steel. Again, back to the benefits of not painting. We've seen a lot of requirements just get worse and worse regarding prepping steel before it's painted. You know, in the old days, you used to break the corner of steel before you put the old red lead on it. The old red lead had a propensity to kind of run away from a sharp corner. So that's why we broke all the corners before we put red lead on in the old days. And succumbing to the old idea that, gee, if something is good, then more is better, some states actually said, okay, don't just break the corner, you need to radius the corner. And they actually had inspectors with a piece of like a credit card with a 3/16 radius or whatever cut into it, and they'd run down the length of the edge of that girder flange and say, well, no, hit a little more here, hit a little more there. When in reality, today's paints don't have that same property of drawing away from a corner. The typical zinc paints that we're using today actually will build up on the corner. But some states still have some pretty onerous requirements for surface prep. So if we can avoid that by not putting paint on, that's good. Again, we're avoiding the cost of the first coatings. Time in the fabrication process. It takes some time to paint these things. Some of these systems that are being required have a long curing time, especially depending on the humidity and the temperature. And a piece of steel can sit on a shop floor or in the paint bay for maybe a day or a day and a half before it can be picked up and moved to the next stage, because that's just how long it takes to cure. So it really slows things down, getting material to the job site in the first place, and with the need for more and more accelerated construction these days, that's an issue. Probably the most important issue, but the hardest to quantify, is the reduced maintenance cost and traffic impact in the future. You know, we never know what that's going to be. We only know that if we don't have to paint it in the future, it's got to be better than if we do have to paint it in the future. Looking at some numbers, our best guess on the average is first cost savings of 10 to 18% on the steel, just on the fabricated steel to the job site. And again, we don't know what life cycle savings costs are going to be, but they're going to be there. Looking at an example with some real numbers, there is a material cost premium for the weathering steel, 3 or 4 cents a pound more than non-weathering steel. But again, the painting costs are going to be significantly higher. Typically, we see the painting costs going anywhere from maybe 10 to 20 cents a pound, depending on what coating system is required, where it's done, how much is done in the shop, how much is done in the field, what the field applications conditions might be. It can be, get to be pretty expensive. We'll look at a real-world example. This one's a couple of years old now, but the numbers are still good. Nice little bridge in Lewisburg, Pennsylvania. I got to get the rest of my numbers out here so I don't botch the numbers. The bridge is 1,223 feet long. Using a 3-cent premium for the weathering steel, we added $53,000 to the cost of the material alone. At 15 cents a pound, we have saved $270,000 by not painting it. So our net savings, first cost, is $217,000. Well, if these 886 tons weighed cost $1.50 a pound in place, that's fabricate, deliver, and erect. And I'm just kind of picking that number out of the air. It's probably not too far out of line for this bridge, given that it was erected over water. But assuming, again, these 886 tons cost $1.50 a pound in place, this represents about an 8% savings on the erected cost of the superstructure. I'm sorry, the erected cost of the superstructure, which is a pretty good savings. And again, this is just a guess based on what it cost to field paint things today and our best guess of those situations, of that bridge and how many square feet to paint and so on and so forth. So it's a significant issue. Now let's look at some of the design considerations that you need to look at to ensure a good application of the weathering steel. And we're going to reference primarily this FHWA document. Dan mentioned this in his opening slides. I think this was first published in 1989, and there's been a couple of false starts by the FHWA to update it, and I'm not 100% convinced the latest effort's going to move forward quickly, but we'll hope so. But most of what's in here, I think, is still appropriate. There's a lot of general information in here, which is still good. What we're trying to do with the update is get some more specifics and a little more, just a little fine-tuning on some of the stuff. So if you follow these guidelines now, you're still good. What they generally require is again, doing an environmental assessment of the site, looking at the site configuration. This is the first thing we look at. We'll look at the environmental stuff. This would be a good typical site for A588 weathering steel, or A709, something with ends in W. It's a nice rural site, so if you don't like brown, it fits in nicely with the local background. It's clear, it's open, it's going to get a good exposure to sunlight on a sunny day, and it's going to get wet on a rainy day, so you're going to get those cycles. There's not a whole lot of tree overhang or anything like that. Good application, a good site. This one would come with passing colors for site evaluation for climatic conditions, assuming it's not right next to the ocean. Here's another one, maybe a little more urban environment, just based on the houses in the background, but it still has sufficient clearance over the water. If this is fresh water, it's not a problem. It'll dry out on a dry day. Here are these tunnel-like conditions I mentioned earlier. This is actually a rendering from a situation in Michigan where we first ran into problems with weathering steel back in the late 80s. Michigan uses more road salt per lane mile, I think, than any state in the country. And if that's not a true statement, boy, it's awful close to being true. And when you get down here in the winter on these lower levels, where there's probably some kind of sag curve in there, and if the drain at the bottom doesn't stay clean, it's always wet down there, and it's always wet with salty water because it's Michigan and it's the winter time. That water is continually getting sprayed up onto this surface right here, and the steel never has a chance to dry, and it's soaked in chlorides, and they just didn't perform well. It was a bad application for weathering steel. We learned it the hard way, but that's something you want to avoid in the future. What's the definition of tunnel-like condition? Somewhat subjective, somewhat gray. Has to do with vertical walls and how long in the approaches the vertical walls exist, and the clearance on the overhead here. There's no specific guidance in the FHWA technical advisory, So that's what consultants get paid all that money for, to make those recommendations. Some of the details to consider are drainage control. For when it does rain, where does the water go? One of the most important things is at the end of the bridge. If there's a joint here, it's always going to be open. There's always going to be water coming down. The end of the girder is probably going to stay wet a lot. The simplest thing to do regarding drainage control is eliminate that joint. More and more states are using jointless bridges. They're becoming very common. That's the best thing you can do for a weathering steel bridge because it keeps the end of that girder dry. Where we see the most issue with weathering steel bridges and not performing well is typically under an open joint. Reality is that's where we see the most issues with painted steel bridges also. Any of those areas that are always wet and debris builds up, that's where you have issues. And weathering steel is no better than painted steel. Painted steel might be a little better because it just postpones the problem a short time. But really the issue is the joints and the leakage and keeping these areas clean. Here's an example of a jointless bridge in Tennessee. This bridge is 536 feet long and there's not a joint in it anywhere, and it's got integral abutments at the end. Just run through the numbers. 536-foot steel, coefficient of expansion for steel, times 120-degree temperature range, generates a little over 5 inches of expansion over the length of this 536-foot bridge. So that's 2.5 inches at each end. If you put the thing in kind of in the middle of the expansion range, you've got to accommodate a rock of 1.25 inches back and forth in the, how do I go back? In the piling that this abutment sits on top of. This abutment sits on top of piles which go straight down. There's a science to designing integral abutments and accommodating the motion or the movement from expansion, but the fact is it can be done, and it's the best thing to protect a weathering steel bridge. If and when you have to have a joint, try and collect the water that's going to come through the joint. Here's just a simple trough that lives under there, directs the water out from under the bridge and away from the steel, protects this end right here, and if there was another end there, that end too. Rather than just letting the water come through here, which would splash onto the steel on either side without a doubt. So put some kind of drainage control in there under an open joint. More and more people are commonly painting the end of a weathering steel bridge. There is a federal color number that pretty much matches weathered steel. It might look like this to start with, where it's kind of orange and that's kind of brown, but it kind of matches up pretty close. It takes a while for the weathering steel to change the color to whatever it's going to be. And unfortunately, you never know exactly what color it's going to be. Some of them end up kind of orangish, some of them end up kind of purpley. The longer you wait, the closer you get to that purpley color. But it's really a function of the climate you're in, and it varies. So even though there's a federal color number that's purported to match the color of weathering steel, it's not going to be a perfect match. People are going to see the difference after a while, if they're looking up at the bridges. And we're the only ones that do that anyway. So anyway, the recommendation is to paint the end of it under a joint. This shows a little drip plate here. We'll talk about those some more. Assuming that this bridge ran downhill towards the abutment, this drip plate on the top of the bottom flange is to divert any water that will be running along the top of the bottom flange off of the flange and away from the end before it gets there. And we'll see some examples of that later. Here's just a picture of a painted, the end of a painted weathering steel bridge. You can see there's a color difference here. This is clearly very little time after it came out of the blaster, even still pretty clean. Another detail we have to attend to is staining. While the weathering steel is first building up that protective patina, while it's corroding a little bit, some of those corrosion byproducts, they're not 100% tightly adherent. Some of them will wash off and will stain whatever the substructure is below. Some jurisdictions find that very objectionable. There are ways to minimize that and control that. You can't eliminate it, but you can get it to the point where it shouldn't be an issue for most people. One simple way is just go ahead and wrap the substructure during the construction period. Once this steel gets the concrete deck on it, but the only girders that are going to be wet and exposed to the weather are the exterior-most ones. So if we keep this all protected while it's under construction, we're probably going to keep most of the staining off of the substructure. Oftentimes we find that these weathering steel bridges have been fabricated at a shop and they're sitting outside for months before they actually get sent to a job site. We find a lot of the staining happens right there on the railroad timbers that the beam that the girder is sitting on while it's waiting to be shipped to the job site. So if you can, the longer it sits before it gets onto the bridge, the less staining you're going to have on the bridge. But simply wrapping it up, which seems kind of bothersome, but it's really not that hard to do, will help minimize the initial staining. As we move on into service, there's a bunch of different tricks that can be done. Here's a situation where there's some kind of joint here. Water's going to come down here. It's going to get collected on this drip pan, which extends out over the abutment so that when the water finally drips off, it's maybe a foot off of the abutment, and hopefully the breeze will carry it away. There'll still be a little bit of stain down here eventually, but it will be minimized and maybe a lot easier to clean off after a couple of years. There are chemical processes that you can go through. I shouldn't say process, but there are chemical products that you can spray blast these concrete surfaces with, which will remove most of the staining. Here's somebody who's got clever, and they've actually left a couple of grooves in the surface of the piers here, so that the water, the runoff from the bridge is collected on the top of the pier and directed into these little grooves such that it actually becomes an architectural feature. Substructure coating is another thing. These little columns have been actually painted with some kind of slippery coating that the staining won't want to stick to, and it's easier to clean off if you do get any staining on there. Here's the case: if you're worried about the girders staining the substructure, well, just make the substructure the same as the girders. It will never show. This is actually the bridge that I showed the second or third slide of a good example of a good patina, where I was showing you was right in here, and you can see even from not that far away, it's nothing objectionable to look at in that bridge. Here it is a little closer. They've done a good thing down below here. They've kept all the vegetation and the greenery away. This bridge is in Pennsylvania, and clearly PennDOT comes by every so often and doesn't just cut the grass down here, but keeps the greenery away from the bottom of these legs, which is an important thing to do. We talked about drip bars. I'm not sure if it shows in this picture, but right there is a little bar. Same thing on the other side of center. And again, that's intended to collect the water that would run down here and divert it off of the structure before it has a chance to wash down onto the substructure below. This staining has come from just the fact that this rocker bearing is weathering steel also. But you can see it's really not that bad. Here's a little bit of a detail for the drip bars. This is the one on top of the flange, on the top of the bottom flange. This would be the one on the bottom of the bottom flange. Just go ahead and weld them on there and put a little caulking or something in there to make them completely watertight, and it'll send the water away. Surface prep, this is not in the FHWA technical advisory, but if you're concerned about what's it going to look like after it's weathered, it's not a bad idea to run those things through the wheel abrader, through the blaster, maybe just the exterior girder, because that's really the only one that the traveling public is going to see. What that will do is that will ensure that you get a nice even weathering on here. Otherwise, you're going to get fabrication chalk and paint, and you might get a little mill scale on there, which might pop off in 2 years, and it'll leave a spot that's a different color than the other surface that's weathered. So I think most people that are using weathering steel are running them through the blaster at least once, or at least the fascia girder, such that it presents a nice even surface once it finally does weather. And again, just the fascia girder is all you need. This is again that same bridge in Pennsylvania. You can see the underside, nice little bridge. But most people don't see the underside when they're driving down the road. I'm not sure that those of us that are interested in bridges see them very much anymore, because we're probably on the cell phone busy, not even looking at the bridges anymore. Some maintenance things to consider to, again, ensure that you get good service out of your weathering steel. Make sure you're inspecting it. The inspection of a weathering steel bridge might be a little different than a painted bridge. If you did have some kind of issue, some kind of crack or something, it may not be as readily visible because it's going to be somewhat hidden or camouflaged in that protective patina, which is its own corrosion byproduct. On a painted steel bridge, if you've got something going on and you get a crack, you'll see some new fresh rust bleeding out onto the paint. It's easy to find. It's not quite the same with the weathering steel, so it may be a little harder to inspect. Again, control the roadway damage. We saw some of those things. Keep the surfaces, keep the areas around the thing clean from vegetation and dirt. We've seen pictures of steel bridges and other bridges too, where people aren't keeping the scuppers clean, and there's actually trees growing out of scuppers and so on and so forth. Not good for all of the bridge, but particularly not good for a weathering steel bridge. This is all good maintenance for any bridge, but maybe just a little bit more important for a weathering steel bridge. Here's a couple of pictures, a pretty picture of weathering steel bridge. And that's all nice, but what about when you made a mistake and you put it where you shouldn't have? What do you do then? And you find out, gee, I'm not getting the protective patina. It's not building up the way it should. What do I do? First of all, you got to determine, is your corrosion issue a weathering steel issue, a bad application of weathering steel, or is it really just something else, one of those lack of maintenance issues? If it's something else, then address that first. But weathering steel can be field painted. There's been a report the feds put out quite some time ago. They took a whole matrix of cleaning methods, matched that up with a whole matrix of different coatings that could be applied afterwards, and did a whole lot of testing on weathering steel. And they found out that you can go back and paint it. If you find a place where it wasn't good for weathering steel, well, you go back and paint it. So what do you end up with? Well, you end up with a painted steel bridge, and you sort of just got to the first maintenance coating a little earlier than you thought you would have. And it might cost you a little more because you got that extra cleaning process to get all the dirt and the chlorides out of the weathering steel. But it can be saved. So in summary, it works. It needs to be specific to the site conditions, but that's good for most of the United States. Those other areas, the places we need to be careful, there really aren't that many of them around. You just have to be sure. Certainly cost-effective, low maintenance. This presentation was last presented in Florida, where the folks at Florida DOT, who have never used weathering steel, almost never, called me one day and said, would you come and give us a presentation on weathering steel? I thought that was sort of unusual because they have a history of avoiding it. I said, sure, I'd love to, but why? And they thought, well, because we're thinking about using more of it. So I've got some pictures from a weathering steel project, weathering steel bridges in Florida that were built in 1999. There's about 12 weathering steel bridges in Florida right now, and maybe there'll be more in the future. This project was in 1999, 3 overpasses, the guardrails, the light poles, everything, all the steel on this project is weathering steel. It's less than 10 miles from the Gulf of Mexico, so it's on the western side of Florida, just north of Tampa, just not very far from the Gulf of Mexico. And these bridges, I'll just kind of click through the pictures quickly, are performing as well as you could want. The patina has clearly built up. Florida has plenty of wet and dry. You know, you get a little shower every afternoon. The sun comes out the next morning. You couldn't ask for a better case study for weathering steel, which kind of surprised me that knowing they have these and this experience in the state already, why would they even wonder about, gee, should we use more? This is the best example of the best science project to prove that it works in Florida. Here's the underside of one of those bridges. Nice, neat, clean bridge design. I mean, look at this, not a speck of staining anywhere in the pier. Same thing at the abutment. It doesn't show up quite so well on a big screen here, but there's just a little bit of discoloration on the outside of this flange where the patina is set up a little bit differently than the entire rest of the bridge. And I think that's because this side is likely to stay, this little part of the bottom of the flange probably stays wet longer than anything else on the bridge. The rain comes down, gets all over the outside, wicks to the underside, sun comes out, dries this off, but this stays wet a little bit longer than anything else. It doesn't, from where I stood on the ground 16 feet below, it didn't seem to be an issue, but it was behaving just a little bit differently, probably because it stays wetter. Here's the guardrails. Here's, I'm not sure why they didn't just use Type 3 weathering steel bolts on these guardrails, but they didn't. There's the backside. Those bolts are all holding the hardware for the cables. Another one. This one you can actually, again, it washes out on the bigger picture. They've got their drip bars located right here. They actually bolted them through from the bottom. A little bit of an unusual way to do it, but that's what they did. Again, a nice, clean abutments. Traveling public going up that road at 60 miles an hour would think that was a beautiful bridge. That previous slide, we had a better shot of a drip bar. But anyway, I'm sure it was pretty clear what the drip bars are all about.